Hi everyone, welcome to my channel. This video is a part of the playlist on AKS Azure Kubernetes Service Networking. And what you see on my screen is a layered and reusable architecture diagram with Draw.io. I have created detailed videos on how to create this, so if you're interested in learning more, be sure to check that out. Today's topic is egress from AKS cluster. We'll take a look at different options and then we'll deep dive into the egress using the firewall. So the way we'll approach this session is we'll start with the different egress options, then we'll jump on to VS Code and build out the cluster from scratch. While the cluster is building, we'll take a look at some outbound flows, we'll look at how the inbound flows work, some corner cases, and then we'll jump back to VS Code and run some validations from the command line and from the portal. And we'll close out with a few troubleshooting tips. So a lot of action. Let's get started. If you've been following along with me, you would see that we start with what's called a classic hub and spoke design. I have a hub and a spoke and a hybrid hub and a spoke design with a branch connected via site-to-site VPN. This is a common scenario you'll see with your customers. So that's usually our starting point. So you can modify this diagram as per your needs. All right. So that's something to remember. And also at the top right hand corner, I always have the description on the current session because they're all very, very similar. And this is the part of the main series. And big thing to note here is the type of CNI that I am using for that particular scenario. So be sure to keep an eye on that one. So with that, let's get started. So here you would see that I have a demo app deployed, and I have a 3-node AKS cluster with a demo app deployed. And if you look at the default outbound, right? So we've done a few sessions already, and we saw that the default outbound, so this pod, when it reaches out on the internet, the default outbound type was Azure Load Balancer. If we didn't make any change, that's the outbound type. However, other outbound types are available. So let's start with the other option. One option that we have is called the NAT gateway. So you could technically egress from the NAT gateway, and I'll show you how to do that. But you do have to build the cluster with the NAT gateway enabled. There is an outbound type setting, and I'll show that to you in VS Code and in the command line. And the third option is having instance level pip. So let me turn off the NAT gateway and the outbound type. You could see that you could have an instance level public IP on the node itself, and then they can egress. These pods can egress using that IP. And the third and a little bit more complex option, though that's the one we'll deep dive into, is the Azure Firewall. So at a high level, we will egress through the Azure Firewall. So let me show you that outbound flow. So we will egress like this. Okay, and then of course the nodes, when it talks to the AKS control plane and the container registry, we do have to allow those rules in the firewall, and I'll show you all of those rules that we've configured in the firewall. All right, so with that, we have just enough to deploy our cluster, and we'll come back in and look at some corner cases. So let me share my VS Code screen with you. So here I am in my VS Code, and I have taken this from this Azure documentation. Most of the configuration is done using the scripts from there, and I've modified a few sections, and I'll show you where. So we'll just drop in all of our variables. Let's go ahead and do that. And then there are a couple here that you may want to put your own names. I have named them according to mine, but you may want to use your own DNS prefix. All right. And what I have done so far, just to in the interest of time, is jumping back to this firewall. I have deployed this firewall in the same VNet, so in the firewall subnet, but in the same VNet as the AKS cluster. And I've also deployed the NAT gateway just so that we have it all ready to go. We won't be doing the NAT gateway, but just to show you, I've already deployed these two. We're only going to be testing with AZ firewall in this session. So going back here, I have already deployed the firewall, and all of these commands are, I've created a VNet, a subnet, created a NAT gateway, and I've already created, so here's all the NAT gateway setting. I've already created the Azure firewall. For Azure firewall does take time, especially with creation of the rule and everything. So in the interest of time, we are all the way up till here where I've created the firewall, and I've also associated the route table to steer the traffic from AKS to the firewall. And I'll show that to you in the portal as well. All right, so all of the rules and everything is done in the firewall. Again, it's on that documentation link I showed you before. So here we will start with creating more AKS specific things. So let's go ahead and create the container registry. And we will grab the firewall public and private IP because it's already created. I want to grab those. And we will echo the public and private IPs. Okay, so those are the two IPs of interest. And we will capture the VNet and subnet ID. I do want to show this to you in the portal. So let me just grab the IDs first, and then I'll show it to you in the portal. So let's jump back on the portal here. On the portal, you see that I have an AKS Egress VNet already created, and this is brownfield. And then for subnet, I have two subnets. I have AKS subnet, and I have the firewall subnet. And that's where the firewall is already deployed. And the important thing is I have a route table associated with this AKS subnet. And that route table, if we take a look at that, it has a 0, 0 route going to the Azure firewall. Okay, so this is the Azure firewall. So we are already steering that traffic towards the Azure firewall. Now we are ready to now deploy our AKS cluster in this subnet. So let's create a user-defined identity here. And let's grab this principal ID and this ID into the variables. This should all look very familiar. And now let's grant this user permissions, the network contributor role. And so now we are ready to create the AKS cluster. Let's take a closer look at what are the differences in the AKS cluster here. So first of all, as I showed you in the diagram, the plugin I am using is the Azure CNI. So the plugin is defined up at the top. It's the Azure CNI, and you can also see that over here. Other way to look at it is, of course, with the CNI, the node network and the pod network are in the same on the same Azure subnet. Okay, so That's for the plugin. And the biggest thing to note here is I've added this outbound type of user-defined routing. The default outbound type is the load balancer. And if we want to egress using the UDR, we need to set the outbound type to be user-defined routing. I've also added this to be more secure. You could add this command called authorized IP ranges, and you can only allow traffic to the AKS API only from the firewall IP. And I'll show you that flow in the outbound flows when we go back into Draw IO. And let's see, this subnet ID is the ID that's associated with the UDR that I showed you in the portal. And this is our own identity, the user-defined identity that has the contributor role. Again, we'll spin up max pods of 30. And that's it. We can go ahead and kick off this cluster creation. And while the cluster is creating, I want to deep dive into all of the rules that I had created ahead of time, just in the interest of time. So these commands will create the rules for you, but let me show you all of the rules in the firewall. So if we go to resource group and this AKS resource group, let's go to this firewall. And the rules that I created, let's look at the network rule collection. There are a few rules that are already created. So we'll just jump into this. And let me delete this rule. I had created this for testing, so I want to start with this rule already deleted, so that I could show you what happens if we didn't have that rule. But basically, while that's updating, I can still show you the default rules that I've created. So very important that you create outbound rules for NTP, this GitHub content, Docker IO. These rules are needed when you create the cluster. So if you didn't have that, if you had your own firewall, if you did an NVA, for example, you bring your own firewall, be sure to apply all of these rules outbound, so that the AKS cluster can talk to the control plane, to the registry, and all of that. So in other words, when you have the firewall, you want to allow a lot of these rules outbound. Okay, and that's what these rules are doing. So anytime you have a firewall, of course, it's secure, but you do have to maintain these rules. And I've allowed a few of these rules as well. And this all is documented up here in the outbound FQDN rules. I'll put the link in the link below. But basically, these are all the rules that you need for the firewall, for the AKS cluster to reach out. So if you were to do it manually in your NVA, you need to be sure to check that out. So that's the firewalls side of the house. Let me show you one more application rule here, edit collection. And so you have the network rule, and then you have the application rule. I did allow this FQDN rule for us to test out our application. So I have already kind of created this, and this is the service tag of AKS. Okay, so those rules are created using the script that I got from Azure documentation. So that's was all done in the script right here. All of these rules, and they need to be created prior to the cluster creation. So while the cluster is deploying over there, the cluster is deployed. Let's connect to the cluster. Oh, and another thing, we won't be doing this today, but if you were to use a NAT gateway instead of a firewall, notice that the outbound type is NAT gateway. All right, so that's the difference. Everything else kind of stays the same, and you will egress using the NAT gateway instead of the firewall. So this is the command to do that. I may cover that separately in a future video. All right, so let's connect to the cluster. And then let's bring this up a little bit. And we'll do a kget nodes -o wide. Now this is an important concept I want to show you. I expect this command to fail. And the reason is that, we'll get a message like this. The reason this command will fail is because over here, in the authorized API ranges, authorized IP ranges for API, we only had the firewall public IP. Now, when I'm talking from my machine with kubectl, it's unable to, it's not allowing that traffic. So what we need to do is we need to update the firewall rule. We need to update the authorized IP ranges. So let me get my current IP. So this is specifically for us to access the AKS API. And we were only allowing it from the firewall IP. So now I will allow it from my current IP. So let me Control C out of that. Let me get this and my current IP, and we will update it. Update the cluster's authorized IP ranges. And then we should be able to get kget nodes a wide command. And again, this you can omit this step if you don't want to be if you don't want that level of security. But I just wanted to show you that that's one of the useful settings for a secure deployment of the cluster. So once the current IP, once we get this update, we should be able to do kget nodes wide, and then we'll apply the, and then we'll create a pod and run inbound and outbound tests. So while we wait, this does take time. The commands that take time, I have written over here that it will take time. So we'll come back and revisit. But at every point, I'm going to let some of these commands fail so that you could see it's useful for troubleshooting, so we can update, then make the necessary changes. So jumping back here, let's go finish our flows while this command is still running. So I mentioned that, you have to selectively allow all of these traffic, and you do have to allow the control plane to be, in the firewall's public IP in the authorized ranges. Okay, so this is the API access. That the orange flow is that API access with authorized IP ranges. Now there is a scenario that I want to explain to you. Let me just make sure. Yeah, that one's still running. So this is a good time to talk about this scenario. So one of the things that we often see is when you deploy the firewall, the outbound is fine. However, when you try to come in through the load balancer, the return traffic gets asymmetric because your 0, 0 route is pointing to the firewall. So I've often seen this asymmetric routing scenario, and when you are testing your applications, it will fail. So we do have a published solution, and I'll show you the link to that. Um, we do have a published solution, and the way we do that is we you connect to the firewall, and then the firewall, right here. So you connect to the firewall, and then the firewall has a net that nets the public IP. So we call it firewall's public IP, and we DNet, we do a destination net to the load balancer's public IP. And so the flow would be, it will go first to the firewall, then to the public load balancer, and then to your the corresponding application. All right, so we don't go directly to the load balancer. So this is the green flows will preserve the symmetry. And as you can see, the asymmetric routing, like I mentioned, looks something like this, where you come in through the load balancer, but you go through the firewall. And that's the red flow is what is the broken flow. Another solution, and I'll come back. I'll come back to this in the interest of time. Let's go back and see where we are with our cluster. So the cluster got updated with our authorized ranges, and now our get nodes should succeed. So if you ever see this, you know that the reason is because it's the authorized IP ranges doesn't allow your IP where you're running the kubectl from. All right, so let's go ahead and deploy a test pod. As you know, I have this network tools pod. It's just a busy box, and we will exec into the pod. Now we are in the pod. Let me do an IP adder real quick. You could see that I am in the pod. I have an IP address of 10.42.1. It's the same as the subnet because this is Azure CNI. And now if I run curl ifconfig.me, I expect it to fail, and there it did indeed fail. Now, why is that? So the reason it is failing is because it's now egressing through the firewall, and we haven't allowed ifconfig traffic to go through it. So let's go ahead and fix that. I did have that rule, but I removed it so I can show you how it fails. So if ifconfig and same thing, IP address asterisk, and here we will specifically allow ifconfig.me and on port 80, 443. All right, so this, once it completes and saves, we will test it again. It does take a few seconds. So we'll come back and revisit this, but this same curl command now should egress from the firewall, and we should see the firewall's IP as the egress IP. All right, so that's the key here. And then the last thing we will do here while we wait is let's go ahead and deploy. So we're just waiting for the firewall to get updated so we can run this curl again. But in the meantime, let's deploy this application so we can test all the ingress functionality. So this is deploying a 3-tier storefront application. I just grabbed it from our GitHub content. And you can see that it's still waiting on a public IP. So we'll just wait here till it gets a public IP, and then we can try hitting it from outside. So that's the inbound flow. So while we wait for two things, one is the firewall to be updated, and we need to get a public IP here so we can get inbound. I want to show you one more thing. So we come back here, kind of diving a little bit deeper on this corner case and asymmetric routing scenario. Uh, what happens is the service that we just deployed is on the load balancer. So we expect that when we try to come inbound, it's going to fail. All right. So what we have to do is we are going to apply a NAT, and that's this next step in the command line, so that we can facilitate this green flow. Okay, so that's the next step we're going to do. There is also another alternate solution, which is through a private load balancer. All right, so there is an alternate solution where instead of putting a public load balancer, we can put a private load balancer. So let's look at that. How will the traffic flow? The traffic will first hit the firewall, and then we will have the NAT defined to the private or internal load balancer, and then we will not have the issue with the asymmetric routing. All right, so that's the alternate solution. So let's go double check our rule. It still says updating firewall. We can still go ahead and check, see if we get lucky here. We did get our external IP here, so we're good there. And let's check egress one more time. So we will exec into the pod. Now we are in the pod. And let's run ifconfig again. There we can egress, and let's validate that this is indeed the IP of our firewall. So we'll go back in the firewall, we'll go to overview, we'll look at this public IP, and it's the last two octets 4.52, 4114, 4.52, and that is indeed our IP. So everything is good from the outbound standpoint. We are egressing from the Azure firewall. So now let's test inbound. Let's get the service that we just deployed, this service. Let's capture its IP. And let's echo this IP. So this is the load. This is now on the load balancer. Now remember I said that if you hit, so let me update this so that we can run the curl command against this one. Now I expect this to fail. So there, this is not working. The reason it's not working is because of the asymmetric routing issue. So to fix that, we need to add that DNAT rule. So essentially what this DNAT rule is doing is it's DNATing the firewall's public IP to the load balancer's public IP. So this will take, this will take, let me clear this. Um, So let's drop this again. Let me double check. Apologize. All right, yes. So I did add an example set before from my testing. So let me remove that. Apologize. Let's go ahead and remove that rule. So it's not happy about that because I already have the rule from my testing before. So this example set, let's remove that. Of course, it's to my previous IP, so it's still not going to work for us, but let's go ahead and delete that. All right, so we'll delete that. Unfortunately, this will take a few more extra minutes till we update it, but the idea is that we do need a NAT, and that is why currently this one is failing. Okay, so this is not working because it's getting asymmetric. So once that firewall finishes updating, we'll add the example set, and we will run the test again. Okay, and couple three things while we wait. I'll just show you a couple other messages. If you use enable managed identity, in all my videos I've been using assign identity, but if you use enable managed identity, you're going to get this message. Okay, so you'll get this message that you need to grant network contributor role to the system assign identity. So that's one of the troubleshooting tips. The other tip that I do want to give you is about um, like looking in the Azure portal sometimes, and this is going to take a few minutes, so we can take a look at the subnet setting. But if you are in the AKS subnet, be sure that if you were using the NAT gateway and you are using the firewall gateway, you may have an issue with the precedence. Okay, so best is to not have both enabled at the same time. If you do have the firewall, as we saw, firewall did take the precedence, but you do not want both at the same time, so that it's more deterministic. Okay, so I've seen areas. I'm just calling out some areas where I have seen that you could get into some issue when you have two different route table and NAT gateway associated with the subnet. Okay, and then there's another implementation here where, of course, like I mentioned, right, you can have NAT gateway in this design. I had it almost parallel to the firewall, but you could also have it, firewall could be behind the NAT gateway. Okay, so that's another implementation that I have seen. So let's go jump back in, see if our firewall's updated. I do apologize for this because this was already existing. So let's go see. So we'll do a refresh. Let's see. Okay, so that rule is gone now. So we'll go ahead and apply that DNAT and it should succeed. So jumping back to where we were. Let's apply that DNAT rule. That DNAT rule again nets the firewall's public IP to the load balancer's public IP. All right, so now that the rule set is getting created, after that, we still cannot hit the load balancer. So remember that you have to hit the firewall's public IP, and then everything will just work. So with that, in the interest of time, I will close out this video, but be sure to grab the firewall's public IP after you do this NAT, and then you can go ahead and hit the firewall. And at that point, this flow should work. This flow would look something like this. Again, I would just show it to you in the diagram as opposed to being able to. So then you will be hitting this IP. Again, be sure to hit the firewall IP. I did make a note over here to curl against the firewall IP, not the load balancer. And that's it for today. I just want to make sure, let me just quickly check my notes to make sure I'm not missing anything. Yeah, just one small thing I want to show you is when you create the firewall, I did use the DNS proxy setting way at the top, and this DNS proxy setting, and this is useful if you want to leverage the FQDN rules on the firewall. All right, so with that, thank you for watching. I do appreciate your time. Drop me a comment. Let me know if you have any questions or if you would like to see any other video. Reach out, and thank you and have a great day.